Hi, this is me, Mr. Wheeler. I want to give you a little bit of background on chords and angles that we'll need for problem 1250. Okay, so here I've drawn a circle with a center at point C, represented by a little cross right there. I've also got 2 points on my circle, point A and point B, to kind of section off my arc length, AB. And lastly, I've drawn a line connecting A and B straight through the circle, inside the circle. So we call this type of line that connects 2 points on the circumference of the circle, but the line goes inside the circle and never leaves a chord. Okay? So basically we got 3 things that have AB in them right now. The chord is this straight line distance. Okay? We would call that line segment AB. That's the chord. We've got this arc length from A to B, the distance along the circle, the section of the circumference from A to B, and then we got this, what we call the subtended angle, okay? And often we'll talk about the arc from A to B, however many angles, however what percentage of the circle is being equal to this angle right here, angle AB. All right, now I've also drawn 2 other points, right here and right here. I don't have them labeled, okay? What I've labeled is this angle we get when I draw a chord here and here, okay, and we make a triangle. Now it's not entirely obvious, but one of the theorems that we get is whenever I've got this chord right here, okay, and I make 2 triangles this way, connecting to the third side of the triangle being this chord, and of course these are also other chords, they don't necessarily need to be the same length. What I get are 2 equal angles. That's why I've got theta here and theta here, indicating these are equal. What you end up with is this relationship. The measure of angle theta, okay, is going to be equal to 1/2 the measure of angle AB, okay, because the chord is segment AB, okay. The chord has this subtended angle, right, equal to the arc right there, and it's 1/2. Now the easiest way to see that, I'm going to draw on this a little bit, is to go ahead and draw a line connecting T and G. This is obviously a diameter because it goes right through the center of the circle. So we see when we draw 2, now I've intentionally put this point right here, okay, and it does, if we look at this kind of closely, make a right angle right here. So I've got 90 degrees right here, 90 degrees right here, and obviously when I draw these 2 chords to connect this point back here, okay, what I've got is I'm kind of drawing my 1/2 of a square. I've got a right angle right there inside the circle, because what do I have? I could do another line up to this imaginary point right here. You can kind of see that square shape taking place. So what I've got right here, basically, this whole thing right here, this chord, GT, okay, all right, that arc length, okay, is 1/2 of my circle, so that equals 180, okay, and then, so angle GT divided by 2 equals 90 degrees, okay? So that's how I get, okay, this particular angle right here. So let's just go ahead and give this point, let's see, we'll call this point D right here, okay? So this angle right here, which we're going to call TDG, okay, is going to be equal to 90 degrees, okay? Right, so whatever arc I have, okay, even if it's 180, so this angle right here, 180, this angle right here then becomes 90 degrees. The real important kicker, the one to look for, because this will show up all the time, is one like this, where you got these, and look for these little points, these little arrow points connecting to the circle, and lo and behold, when I draw them out, they connect to the same points, okay? Kind of like you can kind of go either way from those same 2 points. You'll always have the same angle here. We'll see how that comes into play on problem 1250 when you look at that. Thank you for watching this introduction.